Thanks for coming. Long day, I know, so I really appreciate you showing up. Hopefully, at the end of it, you'll think it was worth your time. So I'm Mark Pollack. I started a project not too long ago now, maybe a month or two, on using Spring to develop AI applications. And I'm going to present on that topic now. So there's all that. Oh, this is, yeah, wrong slide. So why are we at this talk? I think a lot of people were super taken with ChatGPT. It was really a viral success. 100 million people in 2 months signed up. Some kind of record, I believe. And you can kind of see like it really works, right? If you play with it, you see it makes sense. And there's a whole landscape of use cases that this opens up. You can ask it to summarize docs. You can do Q&A over docs, sentiment analysis, code generation. I did an example of that in the code theater earlier today with the Spring CLI. And I think perhaps what's most important is that AI and machine learning really used to be the realm of specialized developers, particularly in the Python ecosystem. But as things have evolved over many, many years, now it's much more accessible to Java developers than ever before. As a sort of example of how much the landscape has changed, this is a quote from a podcast from Daniel Witnack. He's not just a data scientist, but one that kind of does the conference circuit and does consulting and has built up companies. And he's saying, he has to rebuild his intuition of how he does his job. So it used to be that when he was given a task, he would run off, make a model, and get some data and train it. But now he doesn't need to do that because he can solve this without any training. And then he starts to lament on how he's doing software engineering and not machine learning, which is bad for him, but good for everyone in this room. And the primary reason for that is the P in GPT. It's pre-trained. And that really removes a lot of bottlenecks from the point of view of a Java developer or even a Golang developer, you name it. And so AI is really becoming more of a developer tool than it is a specialized niche in one particular segment of computer science. And so what are the consequences for all of us here as Spring developers? Is that software background, super essential. And it's not just, I know how to make an API call to a remote server and get the result back. When you're developing real solutions, you have to incorporate lots of components to make a real-world solution. So data access, if you want to query over your docs, well, you got to get the docs, you got to pre-process them, and you'll see you're going to have to store them somewhere. A lot of this involves doing batch processing. Seems to kind of never go away. And once you go beyond like a hello world application, what you'll see is that the application makes multiple calls to the AI model. And along the way of these multiple calls, decisions have to be made. So I was joking with, I think, Artem or someone else earlier. It's a bit like the old integration patterns example of the hot and the cold drinks, and they get split up, and then they get joined together. It's exactly like that. Based on a certain result from the AI model, you might choose a different path. And in fact, that path might even be chosen by the AI model itself, which leads to this kind of like notion of agents that can decide things. So bringing the whole Spring Frameworks toolkit to bear is going to be really sort of a big end goal of this project, not just making it easier to talk to the APIs that these AI models offer. So what do you need to know? Well, we'll start with the hello world and get our hands a little wet with what the code looks like. That's kind of probably what people are used to because everyone's so used to ChatGPT, typing and getting an answer. But then we'll do a sort of primer on what I guess you would call the domain models or the space of generative AI. And those nouns, let's say, of the space, the domain model, really map one-to-one onto what you'll find in the Spring AI library. So we'll go over the programming model and also some of the more real-world use cases. So it's a new project, really new. There's not a release yet. It's not even in the official Spring repo. It's just in this experimental area. So you're really getting a sneak preview of things to come. And that's the URL. You see it's in an organization, not Spring Projects or Spring Cloud. It's in an organization called Spring Projects Experimental. And you always sort of stand on the shoulders of giants. You know, AI has been going on as a field in computer science since the 60s. You know, so I just didn't like walk into the room and invent this stuff, right? Kind of did my homework and, you know, looked around in particular at which projects in the Python ecosystem, because it still is a leading ecosystem for this, were the most popular, and looked at their domain models under the covers and kind of found these two as the best examples. LangChain is one, LlamaIndex is another, and sort of mixed and matched the concepts to come up with a kind of good, coherent, more object-oriented domain model for the space. So those two projects take, you know, a great deal of the credit for sort of structuring the initial problem. And part of the reason I got inspired to do this was I was listening to a podcast of, I think, the LangChain, or maybe it was LlamaIndex, I can't remember, Jerry Liu, and he sounded exactly like someone who was talking about Spring. He was saying, we provide these abstractions to the AI models so you don't have to worry about changing your code when you switch models. I was like, that sounds like something Spring does. And the more he talked, the more I realized how, in essence, the spirit of what they were doing with their component abstractions were very much aligned with what you typically would find in a Spring project. So some of the key components, of which we'll only touch on a brief, small number because we don't have a lot of time, are what are the AI models, what is sort of the data and how you manipulate data to get data in and out. And we won't go into it, but I think you can envision what a chain is. It's a sequence of calls. And evaluation is also very interesting. A lot of people in the beginning, you know, you're happy just to see something wiggle. But then if you want to move this into production, you'd be like, well, does it really work? How do I know it's really working? So when you're eyeballing it and getting the responses back, you're like, it doesn't work. And then you change something, you go, oh, now it's working. But what happens like 2 months in or one day into, you know, deploying this? Is it still really working and not eyeballing every request and every response? So that's where logging and infrastructure dedicated to evaluation come into place. So here, one-liner, right? There's an abstraction that talks to all these different AI models. We call it AI client. And it has a method called generate. As a convenience, in the early getting started period, it has a string. That is what goes into the model, and a string comes out. And the word generate is kind of like one of these generic terms. You know, like you could generate text, you could generate images, right? So sometimes people use the word completion, but you don't really complete an image, right? So pick the word generate, and we'll see how that goes. So you don't have to instantiate the AI client. There's a Spring Boot starter. So you just put that in your dependency, and off you go. And so what I mean here by Java SDKs are all similar but different is that there's an SDK. We only provide support for 2 of these language models. They're actually hard to come by. You can't even like get access to Google Bard right now, unless you're like in the inside track. So if anyone's on the inside track at Google, let me know. So they kind of look the same, but yeah, they're different. It almost seems like the way database APIs were before standardization of ODBC and JDBC way, way back. So really all you need to provide is the API key, because it is a remote call. And you know, you have to usually pay for your API key. So we'll jump into the first demo, which is Tell Me a Joke. So I have here a project that is the end result of the workshop we gave with Microsoft a couple days ago. So in that workshop, it was a hands-on workshop where we went step by step, building up from zero. To squeeze this into 45 minutes and still cover a breadth of topics, I'm not going to start from zero. I'm just going to show you the complete solutions. We'll walk through the code, and then we'll run through the code. So here's what we showed before. I put it in a controller so that we can invoke it, through a curl-like request. And so here we have the code basically we showed before. Whoops, could probably get rid of this completion. Police is just wrapping it up in some simple JSON, so it's just a string. So I'll run the whole application, and what we'll do with it this is the documentation for the workshop. We're going to end up using this utility called HTTP-PY, which has a command line called HTTP. It's a kind of better replacement for curl in the sense that you can more easily give it request parameters. And I have the key in my environment variable. So we'll spin this up. I'll make another terminal window here, and we'll make a request. So why couldn't the bicycle stand up by itself? Because it was too tired. Yeah, okay. They're all dad jokes. So you see, very simple to get started, right? I mean, I didn't start from 0, but you can imagine this is not, I'll show you the POM. There's not a lot going on there. So starter web, actuator. Here's the starter for AI Azure. If you want it for OpenAI, just remove the word Azure. And then we have to put in a repository definition for snapshots. So there's documentation that goes over that in the website. If there's any issues there, because there have been a lot of little mistakes along the way, let me know. So here is kind of, I'd say, the major nouns, right? The major domain concepts, really at 10,000-foot level. The first thing, of course, are the models. Which model do you use and when? We won't get too much into how much they cost, but you should definitely look at that. And there are things you can do to reduce costs, and you're going to have to be aware of how much these things cost in the sense of when they're being offered as a service. If you have your own model at your own on-prem site, then the cost is just the cost of running the computer. So prompts are the input. Tell me a joke. That's considered probably the hello world of prompts, but they get much more structured and much more sophisticated. And this is probably the first real skill. It's a skill that now is even getting its own term called prompt engineering. So it's called ChatGPT because it really just wants to chat. And when you want to get something like JSON out of it, you basically have to tell it, don't chat anymore, just give me the results, right? Or sometimes you have to say things like, if you don't know, don't make up a story, don't chat. Like you literally have to tell it this. It seems like insane. Sometimes it almost seems like rude because you kind of think of it as a person and you're telling it commands, right? It seems a little off-putting. So there's a whole rabbit hole we can go into there. But I'll leave that for another time. There's a similar challenge in getting the results back out. So it just outputs a Java util string, right? Which is great for a little chat box in your window. It's very bad if you want to use this for data processing and then passing that data on to a next step. So you need a way to get structured output. I already mentioned enough probably about multiple invocations. And use your data. We'll get to this near the end of the talk. This is its own little subdomain, right? And this is probably where a lot of people will spend a lot of time because they want to use this technology on their own information. And so what are the techniques that you can teach an AI model about your data? And this brings in concepts like data loaders, an abstraction we call a document, which is really now just string text, but it could have an image in it as well. And then you'll see, in order to implement this solution, you got to bring in kind of a little host of technologies, right? One of them are vector databases, which are very good at returning text that's similar to other text that you've given it. And then last is evaluating. I mentioned it before. How do you know that the solution is working? So here's the lowdown of the models. Maybe going from bottom up, the lowest entry point there is text to numbers, right? Which sounds so boring, right? For end use case, but it's kind of like foundational. People probably got their PhDs working on efficient ways to convert text into numbers, because these numbers, sometimes called embeddings, are really how the guts of the AI model work. So it's kind of like text to numbers go into the model, and then numbers to text on the way out. And then before ChatGPT, took the world by storm, like the previous summer, I remember friends, showing me on their phone, I'm going to type something and it's going to generate an image of whatever I type. So it's like, John Lennon, sitting on a school bus. And all of a sudden, it's like, John Lennon sitting on a school bus. Like, who would have thought? That was like Mid-Journey and Stable Diffusion. And that kind of caught on. It was popular, but not as popular as ChatGPT. But in the context here, the input was a language or an image, and the output was an image. Similar for OpenAI's product called DALL-E, another one called Deep AI. And then we start getting into the GPT era, or the era where the input is language and code and the output is language and code. So, there are three main ones. There's Anthropic as well. It's probably 4 or 5. And it's probably long tail. Everyone, probably the VC community is going crazy, probably investing in companies that are trying to catch up. So language code input, language code output. And now you see this line on the top is language code and image, and then the output is language and code. Then it'll be /image. A year from now, it'll be /video, right? So it's becoming like a multimodal model. That's what they call it. So right now, depending on what you want to do, you have to pick a model. But I bet you a year from now, there'll be models that just do it all, which is pretty impressive. The downside of chat models is that it just makes stuff up. So that's what I was saying before. In the prompts, you have to say, if you don't know, just say so. And that hallucination, goes from just flat out lying to little subtle things that screw up maybe how your output parsing works. You ask it for JSON, it says, sure, here's the JSON. You're like, okay, I don't need the sure, here's the JSON part. I just need the curly brace in the beginning. So that's sort of an example of a, hallucination in a way. So prompts, this is how you get the output. You can't emphasize enough how much this is an important skill. There are a lot of techniques, but there's really no equivalent of SQL yet. I'm sure we'll get there at some level, because it's really meant for human input and language. So there's guidelines from OpenAI and best practices, and you can scroll through this, do this, don't do that, do this, don't do that, do this, don't do that. It kind of understands things like placeholders, extract the words from the text below. I don't know if you can see it. Oh, it's so fuzzy, isn't it? Maybe it's my eyes. And I would recommend also there's, oops, how do I get back to my slide? Yeah, there's a course from a company called deeplearning.ai. Also very good. Yeah, this one. Yeah, in collaboration with OpenAI. So they kind of give you the little tips and tricks for their model. And so prompts in Spring, so really, essentially it becomes analogous to the Spring MVC concept of a view where you have a template engine, and normally it was generating HTML, and you had a model, and you substituted the placeholders in the view with the values from the model. That's really, really very similar. And the reason it's important is that you have to write pretty lengthy prompts telling it what to do, and you don't want to just hard code that, in your file. You want to externalize it, much like you would have externalized, a velocity template back in the day. Whoops. Yeah, so here's an example. What we use under the covers for this class called prompt template is Terence Parr's string template library, right? So you can see how it's kind of turtles all the way down, I suppose. So here's like a simple example, not one that we're going to do, but you really kind of describe what you want. You want maximum 500 words. You only want 5 points minimum. So you're guiding it to influence the response. And these are the placeholders. So normally what will happen, you'll get into an iterative cycle. Like the first time around, you know, you would have gotten 2 bullet points, and you're like, I really want more, right? So then you go back here, and you say 5 more bullet points, right? And you do it again. You're like, oh, that's better. And then you say, well, it was kind of chatty. Can you make it maximum 500 words? So you do this for a while until you get the prompt you want, and then you save it. So here's an example of how you can do it. You can create an instance of this prompt template class, give it the string with the curly braces. And if you're wondering why it's a single curly brace instead of doubles like handlebars, which everyone's probably more familiar with, is because in the Python community, they used a format called f-strings. And f-strings use single curly braces. And so that's okay, but the real reason is that people share prompts. There's like prompthub.com, I'm sure, right? I don't remember all the names, but they're the equivalent of these things. So it's very good to go to these websites and say, I'm doing something like this, and out comes a prompt, and you now can cut and paste it because those websites have really been developed by the Python community. So you give it a map, and then you ask the prompt template to render, you know, your string, passing it the model, and send it off to the AI model. So we'll do that one next. So I think this is still running. Yeah. Okay. So here's I'll just walk through the code briefly. Right. So we're going to pass it optionally an adjective and the topic. For, you know, create me an adjective joke about this subject, right, or topic. All right, this is where we get to do Mad Libs. So I need a noun. Who has a noun that we can type in here instead of cow? Chips. What was it? Chips? Chips. Like potato chips?
Poker chips.
Poker chips. All right, let's do poker chips. I guess I use double quote? I don't know, I'm not an HTTP maven here. Why do poker chips go to the doctor? Because it had a chip on its shoulder. There you go. More dad humor. Yeah, so you can play with this all day long, right, and entertain yourself. So we'll talk now about output parsing. So the challenge is, you know, what you get out is literally a Java util string. And some terminology you'll find, which is important to know, is an abbreviation called LLM, stands for Large Language Model. That's kind of probably some taxonomy of, you know, under the covers where this thing has come from. I just kind of generally use the term AI model, but that comes up quite a lot. And sometimes if you ask for JSON, you get a JSON string, but it really wants to talk. And so it's hard to get it to talk to JSON. Output JSON as an example. It's become like the little focal point for JSON. And so before a few months ago, June 15th, you know, there was probably, you know, dozens and dozens of blogs saying, I found a way to make it always return JSON 99.9% of the time. And then, of course, first in the comments were, try this. And didn't do it, right? You know, so OpenAI realized there was a lot of frustration in the developer community. So they actually put in a feature called functions, which is a little bit more broad than just asking for formatting. But part of its scope is to really give it the schema, the JSON schema of what you want. And now it knows, because you've given it the schema and you've actually given it in a role called function, so it knows what it needs to do. And they've trained the model to know about the fact that it's going to be asked to produce JSON. So we don't have the function support yet. We'll have it soon. But I'll show you kind of what the state of the art is, more or less, before you use these features. And not all models have them. I know right now we only support these GPT models, but if you went to Bard or you went to Anthropic, they don't yet have this function capability. Yeah. So we're going to call a endpoint called AI output, and we're going to input an actor. And what we're going to do is we're going to create an output parser, which will map the JSON into a Java bean, because we're all into POJOs. And so there's a very simple class that just has an actor and a list of movies. And here I just put the this line here gets the format, and we'll take a look at what this is and how sort of obnoxious it is you have to talk to it. And then we create a message, generate the filmography for the actor, and then the format is the stuff that came out as output bean parser. So you don't really need to know what it is. You're going to see it, but it's made for you. Then we process this user message by rendering it when we call create. And now we have this class called prompt. We won't dive into it too much, but it's the next level up from string. Like in particular, there's things we won't get into too much called roles. You have a system role and a user role, and the system role is where you're kind of giving it instructions on how to respond to messages or text that's in the user role. So, strings are how you start, but then you get to more structured stuff. Similar on the output, so you pass this, and you get something called a generation. Generation normally just has your text that came back out, but also has things like usage statistics that kind of relate to how much money you're paying. So you can kind of collect those and figure out how much money you've been spending. And other metrics and so on come back out. So now we have the response in this kind of more structured object. We get the text, we pass it to the output parser, and then we'll just chuck this back over the wire and get our JSON representation. This is useful if there was a chain, right? I wanted to hand off to the next thing in the chain, a Java bean, so it could work on a strongly typed object. So go to the output parser. Yeah, this just explains it. That runs it. This would be a long list. And I think did I log the, So there we go, the actor in the movies. And I think in this run window, yeah, here. So the format is your response should be in JSON only. Don't include any explanations. Only provide RFC format. And here's the JSON schema it has to use. And in particular, it uses draft 2020-12, which Jackson library doesn't support. So I had to hunt down a library, and thankfully there's some great person on the internet who finds the hobby of implementing all the JSON schemas and generating them from Java Beans. So I found that library, and then you just encase it here. And this is kind of on the way to what is required to use functions, because you have to pass the schema in order to use functions. And then you can ask it for other actors, but that's kind of beside the point for this demo. Okay, so what are the limitations of the AI models? First limitation that you have to know about is that there's no information past September 2021. So basically, it's 2 years old information. And it will nicely reply that it doesn't know anything if you ask it about it, something in 2022. Sometimes it makes up a little story, which is entertaining, like predicting where it might be or some event or whatever. And the second limitation are things called tokens. So when you type in words into the prompt text, again, all computer science stuff, right? Doesn't want to deal with words, wants to deal with numbers. And those numbers are called tokens. It's like, okay, that's the internal stuff, right? 1 token is equal to 0.75 of a word. I think the stat is all the works of Shakespeare is 900,000 words, which is 1.2 million tokens. I think The Great Gatsby is 100K tokens. And so these models have limits, right? So GPT-3, question in the back. You have to ask a PhD in computer science. It's the way it is. GPT-3 had 4K token size limit, GPT-4, 8K, 16K, 30K. You can see where it's going. Meta has one at 100K, and I think they made a research paper of 1 million K. So for example, let's say in The Great Gatsby is 100,000 words, let's just roughly say 100,000 tokens. If you want to get a summary of it, you can't just chuck it in the prompt, right? Or for example, the case of all the works of Shakespeare, you could chuck it all in the prompt. I mean, you can't chuck it all in the prompt anyway, but even if you could, even if you had a model with 1 million, and you're only asking about Hamlet, why would you pass all the works of Shakespeare in the input when you're going to be billed on how much tokens that's there? So you have to get into this kind of curation of what you pass to it to not just meet the limits of the size of the window, but so you don't overpay, you know, and even though you're not paying when you run it in your local data center in terms of the same bill you get from Amazon or OpenAI or Azure, you're still burning CPU and electricity, right? So it's going to cost you something at the end of the day. So there's some efficiency here. And a lot of people in the field call this the context window, almost like a mental context window. So if you give it more than that, it just doesn't know. It goes right to dev null. And what's important as well, small detail, what counts against this token size is not just the input, but also the output. So it's really the whole sum that matters. So these are the techniques you can use to teach the model about your data. When I think these models were smaller, it was quite common to do what they called fine-tuning. This is where you put the bat signal up to get a data scientist and said, I need to change the weights on this model. And it was hard to do. The bigger the model, the more expensive it is. It could take weeks to retrain the model. And now with these models like GPT-4, they have 70 billion parameters. You know, OpenAI and Microsoft, to make one training run, basically use like their whole data center for 3 weeks. It costs them millions of dollars. You're not doing this with your home gaming rig, right? It's so out of scale. So someone, I'd love to find out who, maybe it was intended this way, but it kind of seems accidental because the terminology around it is literally like called stuffing the prompt. It almost feels like a form of SQL injection, hacking the prompt. So what they do is they take the information that's relevant and they shove it in the prompt. So that's the first step. So example we'll show is that we'll ask it about the 2022 Winter Olympics. And since that's after the cutoff date of the model, it's going to reply, don't know what you're talking about, and some comment. I'm curious to see what comment it'll generate again. But in the middle, what we'll do this time around is we'll give it the text of the Wikipedia article on curling for the 2022 Winter Olympics, and then ask the question again, and now you'll see it'll give an answer. So where is that? Here we go. So there's more resources going on here. So this is the docs to stuff resource. It's a conversion from the Media Wiki Markdown, which is the worst Markdown on the planet, to GitHub flavored Markdown. So here you'll see kind of the information, right? If we go back to here, here's the question and answer prompt. Use the pieces of context, so I called it context. Also this, disclaimer, if you don't know, just say so. That's important when we pass nothing for the context. It's going to answer we don't know, instead of making stuff up like it likes to. The way we run this one is over here. So I think the question we're asking, I changed it from the docs, is which athletes won the mixed double gold medal in curling at the 2022 Winter Olympics? Oops. So this one, we told it not to put anything in the prompt, and it goes, sorry, don't know. And now we'll ask it to stuff it. Sounds bad. So there you go. Those were the winners. Now we've taught it something. So we've kind of taken like the first step to teaching it about our data. But because of these tokens, oh yeah, question?
Just the stuff that you stuff it with, it counts towards your token.
Yep.
Right?
Yeah, I think that was around 9K tokens.
Yeah, okay.
Because someone tried this on the OpenAI model, not the Azure one, and I think it was 4K they were using, and it was Josh, because Josh Long, was kind of hacking on this. Yeah. So yeah, I used a lot of tokens. I don't know. For this casual use, they're not expensive, right? But it's like, death by 1,000 cuts, I suppose, if you make it available to a large user community. So you can't fit all your data in the prompt. That's just one article, right? What if I wanted all the articles on Wikipedia on the entire 2022 Olympics? That article was 9K. I'm using a 16K model, so I'm right at the limit right now. So there's this technique called retrieval augmented generation. This is a technique that was used in the keynote that Adib and Asir gave with the bicycle store. And so I'll show you some of the code that was used to implement that bicycle store agent, chat assistant, whatever it's called. And so this is a technique to present to the model only the most relevant data for your query. And I'll just go over the high level and we'll walk through the code somewhat quickly. I only have 7 minutes left, so it's hard to stuff it all in here. But this is basically 2 steps. The first step is data preparation, batch job. You get all the Wikipedia articles, and you cut them up, which sounds easy, but it's not. Like, you don't want to cut it up in the middle of a table, for example, because then those are 2 pieces that might not get retrieved later. So you kind of have to figure out not only where a good place is to chop it up, you also can't chop it up so that it's bigger than the token size, right? You can't just take the whole article and say that's one chunk. So there are implementations that can calculate ahead of time how many tokens this chunk is. And so you kind of set a limit, and you also set like an overlap, right? So it gets a little sophisticated, definitely beyond what you do in a cup of coffee right after work. And so that's the value of these libraries. They provide these pre-built data loaders, pre-built splitters. If you're splitting over code and you want to chat with your code, don't cut it off in the middle of a function, right? Otherwise, it doesn't make any sense. Then you convert this text to numbers, kind of like the tokens, but a little different. These are numbers that are called embeddings that are useful to store in technology called vector databases. And what vector databases are good at is giving you back text that's similar to what you put in, right? So it's very good for this kind of Q&A type stuff. And there's a whole, field around this. There are sort of databases you're probably familiar with that already support this. Redis is one, MongoDB is another, Postgres has this feature. But there's also whole industry of vector databases that have emerged solely for the use case around machine learning and AI. A good one from the open source perspective is called Chroma. Very easy to get set up with. It's open source. You can run it locally. Seems quite nice from my limited experience. So this is like the batch job loading aspect. And now when you ask the question, you have kind of more steps involved. So you put the question to the side, and then you go to this vector database, and it retrieves relevant documentation, right? And apparently the magic formula is something called cosine similarity. And it's basically like, essentially, you have 2 vectors, and they're pointing in the same direction. They're similar. If they're pointing, opposite, then they're unrelated. And if they're pointing like that, they're unrelated. So it's like similar, unrelated, opposite, right? You get the relevant bits, 2 or 3 fragments. It's usually more, And usually what you want to do is retrieve as much as you can up to that token size limit if you want to ensure the best. I guess this is all about the tuning, right? About how much to give it so you finally see effective results. So you can make a feedback loop really with these evaluators to figure out the minimum size so it's still effective. And then you get your answer. So I'll do the demo of that. I'll walk through the code first. It's going to be probably a little hard to comprehend because there's a lot of concepts. And the next step, you're saying, I don't want to write all this code. And that's where chains come into play. So the first chain I'll write when I get back home will be condensing all of these steps, basically so it's a one-liner, right? So those steps are repeated over and over again, and so it just gets bundled up into sort of the utility, and then you could reuse that utility over and over, and it'd be very simple. So here it is. So now we have a service, because it's getting a little more sophisticated. So step 1, have something called the JSON loader. So the documents for the bike store are all in JSON. Here's the name of the bike, the price, description, and then you can have metadata, which even gets more sophisticated, but we won't get into that. Like imagine you had more than bikes, right? And so you'd first filter by the bikes, and it kind of becomes like the where clause in the vector database. But since we're just talking about bikes, we don't care about that sophistication. So we load it up and we say we want these 4 fields. And even in what I was doing, it was kind of important. It turned out in the document it was given that the price was after the short and the long description. So when I would ask it about the price, it didn't know because it got chopped off. So I put the relevant information closer together and then it worked. Right? So these are the kind of things you'll have to think about. I load it into this abstraction we call a document. And here's where I load a vector database and wrote one that's in memory. So you don't have to rely on any external service. So it's a toy example, but it works well enough. So this is where we actually call out to a model, and it'll take a little while when it runs. We call out to the model and say, give me an embedding for this chunk, give me an embedding for this chunk, give me an embedding for this. And then we store those in the document. And now we're going to start. So I'm doing this all in one go. Yeah? Question in the back. Yeah, what I mean is probably best to explain with the picture is this. You chop it up, and now you have these little fragments of text. In your mind, just think about it as like, paragraphs in, Markdown and HTML, like little snippets of the full document. And since these vector databases, just like we were talking about tokens, they don't operate on words. They operate on numbers, some abstraction, right, of words. So you convert, if you look at what the embedding is, it's a long array of floats. So you store all these floats in this vector database. Now you got all these numbers sitting in there. You come along with your question, you take the embedding, you convert that little snippet of your question into this array of floats, and you ask the vector database, this array of floats, give me the documents that most relate to this array. So it's kind of deep magic here in vector databases. It's kind of like, efficient, it's not just like a random grep over, a bunch of things. It's very good at what it does. So it's a very special purpose database for similarity search. And so these embeddings, it's just part of the magic of it, right? And when this becomes a one-liner, you kind of largely don't need to even really pay attention. Unlike other things where you need to fine-tune it, the thing you need to fine-tune most here is how you split it up. But that stuff is kind of like rock solid. So this was the user's message, right? Way up here. Oops, sorry. Retrieve message. It's going to be something about the Olympics, right? Or the bikes, sorry. So we get the list of similar documents. And now we create a message from these similar documents. We create a prompt from that message. And we send the prompt off to the AI model, and we print the response. I know it's a lot to take in, but this is kind of like one of the key recipes in order to implement something like query over your README files in your company, or query over your wiki pages.
Does it just reduce the input prompt size?
Exactly. That's exactly the point. Because you're stuck with, let's say, 32K, but all the Wikipedia articles of the 22 Olympics, right, is way, way larger than that prompt context window size. And so when you want to do summarization, it gets even a little more weird, right? You have to summarize the first part, and then put that to the side, summarize the second part, combine those two together. Then, so it gets funky. It's like a map-reduce problem of sorts. So I will go to the retrieval augmented generation one. So enter that. So it is splitting up the text. And so each part got broken up into different chunks. I just wrote it in memory one. Oh no, so the embeddings are a client call to OpenAI. Yeah, so it's doing it, yes. So these were the similar documents that came back, that we passed in. That's printed out here. And then we'll look at the response. It says, both the Allegiant and the SwiftWrite Hybrid, are good options for you. Now we can start asking it more detailed questions. Tell me more about this one. And because I didn't write this efficiently, it goes back and does everything all over again from scratch, which you would never really do, but this is a demo. So it's a hybrid, versatile, efficient bike, blah, 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 right? And so you can keep asking it all day long about the bikes. And chat, again, brings in one more concept called memory, right? So this is only knowing what I've spoken about now in the context. If you want to have a real chat, you have to preserve what you said before somewhere and then shove that into the prompt. So that's what ChatGPT is doing. It's constantly taking your previous questions and putting it back into the prompt until such point it knows it's reaching its limits, and then it starts to condense everything you said before and tries to summarize kind of what you're getting at. Which is why when you have all those tabs open, it's very good to kind of keep the same conversation on point, right? If you're talking about Java, don't start asking about Winter Olympics, stuff like that. All right, there's a lot not covered. I hope I gave you a good tour of what this library can do and kind of the software engineering skills that you'll need to implement, effective solutions. And it's a young project, but we'll be investing heavily in it, I think. And it should grow and hopefully be production worthy one day soon. So thanks for coming. We can take any questions you want. Any other questions? So right now it doesn't handle sessions at all. The way sessions were handled in the demo was all the information was stored in the client side. Yeah, so there was some sneaky stuff going on in the demo. So this is that concept of memory I was talking about, which is almost like session management. And so, we'll be integrating the equivalent of session management, with this memory concept, which is a little more general purpose than just handling your session. It's also handling your conversation and other aspects, kind of like a scratch pad. It's a little eerie, the terms that they keep using, in this domain, memory. But it is very analogous, and the reason chaining is a thing is because for complex problems, just like a human would, you have to break it down into steps, right? So you say, step 1, do this, step 2, do that, step 3, and then it's much more effective than giving a prompt saying, do everything all at once. It kind of gets a little lost. So, yeah, it's like having a smart intern. Yeah. Yeah, question over there.
What's the relevance of using a vector database to writing inline using the cosine similarity API, which is exposed by the
Yeah, so I wrote a little cosine similarity thing, but my queries don't take into account metadata, right? So databases are great at handling this, right? So there are features way beyond what you'd write in an in-memory one. And eventually, you have to do things like update, right? What happens when the data changes, right? If you're doing query over your documentation, you make a new release, you got new pages. So you might want to eject some, upsert some others, right? So quickly you're writing a database, and that's what these companies do, right? They write databases for this purpose.
My question is, when do you want to use this? We are talking about this augmented
Yes?
last one we discussed. So in that, if you are only doing chunking your large input and then vectorizing it and then finding the closest to your question vector, you could do all that automatically without even using the vector database at all.
If you want to don't use it in memory, feel free. What I'm saying is these databases are purpose-built for this, and they have tens of engineers making it super usable for all the use cases. So I wouldn't start from scratch and try to compete with them. We can take it offline, maybe. It'd be more effective to have that conversation that way. Okay, cool. Beer time, everyone. Thanks for coming.